Yeah, we are live. We are live. So we are going to discuss previously asked questions in HPCL examination in the branch of electrical engineering. Yes, if you have any queries, you can directly post in the chat box. Okay, you can directly post chat box. I'll be looking at the chat box continuously. If you have any question, you can type in the chat box, and if you know the answer of the given question, that also you can post. That also you can post. See, questions are very easy, very dead easy questions. These are the questions from 2021 paper. 2021 paper I picked. Okay, so some portion of 2022 questions are also balanced, and some portion of 2021 questions are also balanced. So we'll complete in the upcoming session those things also, right? Yeah, come here. What is the first question? Which of the following is not a characteristic of a PMMC instrument? Yes, first of all, PMMC is used for the measurement of only DC, right? PMMC is measured only with DC, and its a scale is a linear scale. PMMC scale is going to be a linear scale, and torque to weight ratio is very high in PMMC when compared to all machines, all I can say instruments. And eddy current damping is used in PMMC. Okay, PMMC is an instrument which will measure milli or microamperes of current. We can extend it as a voltmeter or ammeter. By connecting series resistance, we can make it as voltmeter. By connecting shunt resistance, we can extend it as ammeter. Okay, so these are the basic points of PMMC. Read the points. Which of the following is not the characteristic of a PMMC instrument? Option A is a non-uniform scale. The option A itself is not the characteristic of a PMMC. Yes, the scale of PMMC is uniform, whereas the scale of remaining other, I can say MI, EMMC, all are non-linear. Okay, why? Because there the torque produced is directly proportional to I square, current square. But here, see, the torque produced, the deflection torque produced in PMMC, TD is equal to BI N into A. Okay, so the easy way to remember is Bina is a city in Madhya Pradesh. Okay, that way you can just only for the purpose of remembrance. Okay, B is the flux density, I is the current, N is the number of turns, A is the area of cross section. So torque, the deflection torque is directly proportional to current. Directly proportional to current. Therefore, the scale will be linear. Used for a DC measurement only. See here, this is not the characteristics, and this is our answer. Please, he is asking not a characteristic. Option A is our answer. Don't misunderstand that I crossed it means to say that that is not the answer. That is the answer. Okay, used for DC measurement. Yes, this is only used for DC measurement, and no hysteresis loss. Yes, in PM. Why? Because it is measuring DC. Hysteresis loss and eddy current loss, these losses are going to depend upon frequency. As it is measuring DC quantities, voltage or current, frequency is zero. Frequency is zero. Hysteresis and eddy current loss are zero. See, what is the eddy current loss formula? Eddy current loss is equal to K into B max square into F square into T square, and hysteresis loss formula, that is equal to eta into S B max power X into F into V. V is the volume, F is the frequency, T is the thickness of lamination, eta is some constant, K is some constant, right? X is called as a Steinmetz coefficient. Steinmetz not coefficient, it is an exponent. Steinmetz exponent it is. Okay, so if you see, hysteresis and eddy current losses are depending upon only on frequency. So in DC instrument, the frequency is zero. Therefore, hysteresis and eddy current loss are zero. High accuracy, yes, when compared to all instruments, PMMC is more accurate because the errors are less in PMMC compared to all other instruments. Okay, let's go to the next question, please. Two quadrant type B chopper operates in, yes, it is going to operate in first and fourth quadrants. First and fourth quadrants. That is direct question from power electronics. Two quadrant type B chopper, it is going to operate in first and fourth quadrant, please. Next, exponential signal is an example of, what is the signal? Let me take it as f of t is equal to e power minus 2t. For example, I'm taking, this is an exponential signal. First of all, if I draw its graph, yeah, some questions have been asked from the subject of signals and system. I won't say the subject itself is signals and system. Basic questions are asked from signals and system. If I draw its graph, the graph looks like this. This is 0, right? And this is 1. This is e power minus 2t graph. Tell me, if you look at this, is it periodic? What does it mean by a periodic signal? The signal which is repeating after a particular interval of time, if it is repeating after a particular interval of time, is called as a periodic, but it is not at all repeating. Therefore, it is non-periodic, first of all. And see, it is, yes, it is possible for us to get the magnitude at each and every point. Therefore, it is deterministic and non-periodic. So, deterministic and periodic, no, it is not periodic. Random and periodic, first of all, it is not random, it is deterministic. Random and non-periodic, no. So it is deterministic and periodic. See, I'm expecting from you guys in the chat box. See, I'm expecting answer for the questions from you guys. Very easy questions these are. Okay. Next question, please. Amplitude of an anti-symmetric signal. What is a symmetric signal? First of all, let me tell you. What does it mean by a symmetric signal? Means I will draw one graph. Yes. Look at this one, please. Look at this one. If you fold, this is a t, this is f of a t, this is origin. If you fold this one, means put your hand at the f of t axis. If you fold this one, this left side one is going, right side one is going to overlap with left side one, or left side one is going to overlap with the right side one, right? Yes or not? So this is a symmetric signal. It's not anti-symmetric. I'm talking about symmetric, right? Now, if I draw this graph, you tell me whether it is symmetric or not. Yes, sinusoidal I taken. Yes, this is 0. This is 0. Tell me, this is f of t and this axis is t axis. Tell me, this is symmetric or anti-symmetric? This is anti-symmetric. It is not symmetric. Means if you put your hand here and if you fold, the left side and right side are not going to overlap. The left side and right side are not going to overlap, right? So this is symmetric. This is symmetric. This is anti-symmetric. This is anti-symmetric, right? So if you observe, for a signal to be symmetric, definitely some value should exist at 0. See, the options are amplitude of anti-symmetric signal. This is the anti-symmetric signal. Example of anti-symmetric signal. Don't think that, sir, this is only anti-symmetric. No. This is one example of anti-symmetric, right? Yes, Ajay, this is anti-symmetric. Anti-symmetric. As I told you, you can type that in chat box. Yeah. Anti-symmetric signal is dash at the origin, either positive or negative. Anti-symmetric should have the value of 0. If it is having some positive or negative, the same value should be there on the left side and right side, but then it is going to be symmetric. For anti-symmetric, definitely the value should be 0. Always it is 0. Option is D. Always it is 0. Option is D. See, I'm expecting from you guys, see, always it is 0. Okay, the answers. Next question, please. Find the value of the Thevenin's resistance RTH for the circuit to the left of terminal A and B. Yeah, these are the A and B. Now leave this load resistance. You stand here, as I told you number of times, even in the previous classes also, that wherever you want to find Thevenin's equivalent resistance, you stand there and see from here. You see from here. When you are looking from here, two things you have to do. That is, one is short circuit the voltage sources and open circuit the current sources. You stand here, short circuit the voltage sources and open circuit the current sources. Yes, I am short circuiting this voltage source and I am open circuit this current source. Now these two are in parallel, that is in series with one. So simply RTH, yes, RTH is equal to 4 in parallel with the 12 plus 1. Therefore, RTH is equal to 4 into 12 by 16. Yes, 4 threes it is. So simply RTH is 3 plus 1, that is equal to 4 ohms. Option is D, D for Delhi. Right? Yes. Let's go for the next question. Yeah, same question, it got repeated. Yeah. Electrostatic type instruments are primarily used as, see, electrostatic type voltmeter you might have been studied. The electrostatic type meters are instruments are primarily used as voltmeter. For high voltage measurement applications, electrostatic voltmeters are used. Yeah, primary used as voltmeters, right? Next question, please. An alternator has a per unit impedance of 0.9 per unit. Okay, what that fellow says is X per unit is giving it as 0.9 to a base of 20 MVA 33 kV. That fellow is saying that on the base of 20 MVA and 33 kV it is 0.9. Then the per unit impedance to the base of 60 MVA and 11 kV is. So this is the old value. This is the old value. In our classes, I given you one formula, very simple formula. In fact, I derived this formula. X per unit new is equal to X per unit old 0.9 into, yes, V base new by V base old. See, let me write here. Let me write the formula. Substitution I'll do in the last. X per unit old into, yes, see, X per unit old into S base. See, very simply, X per unit is equal to X in ohms by X base or Z base. Z base is nothing but S by V square. S by V square. So Z base, sorry, V square by S. So it will be S base by V base square, right? So what I'm doing is here, this is the formula. Oh, V base square here. S base here, V base will come here. Let's understand. First of all, see how to remember this formula very easily. I'm telling you here. You have old per unit value. First of all, get ohmic value. First of all, get ohmic value from this old per unit value. How to get the ohmic value? Multiply with the old Z base. What is Z base formula? V base whole square by S base. So V base old whole square by S base old. Now I will do one thing. I'll do one thing. Just a minute. Let me erase this one. Yeah. Just a minute. I'm erasing this one. Yeah, this one also. Let me write near to this one so that it is easy for you. It is always possible for all of us to forget the formula, but once we forget, we must have some very basic method to retrieve the formula, right? Observe here. This is X per unit old. If you do this one, any per unit value into V base by S square is nothing but Z base. Per unit value into Z base is going to give you ohmic value into. Now I want to convert this one again into per unit on new base. If you want per unit value, you have to multiply with the S base by V base new, V base square new. So S base new by V base new whole square. If I do that, I'm going to get X per unit old is 0.9 into V base old. How much it is? 33 by 11 whole square into S base new. S base new 60 divided by 20. So it will be 11 threes. 3 square means 9. This is 2 threes. 3 into 3. 3 square, that is 9. 9 into 3. So its value is 27. 27 into 0.9. 18 plus how much is 27 into 0.9? 18 plus 6.3. How much it is? 24.3 is the answer. Option is D for Delhi. Right? See, none of you answering, man. None of you answering. I'm expecting answer from you guys. Next question. A 200 kVA single phase transformer with a voltage ratio of 6600 by 660 volts has the following winding resistance. R1 primary winding resistance is 1.75. R2 is 0.015. Okay. Find the resistance referred to the high voltage winding. Means he is asking R01 in ohms. R01. One is primary. Yeah, here primary is high voltage. See, if you take the left side one as primary, so that is the high voltage side. So he's asking entire is referred to primary side. Entire is referred to primary side. What is the R01 formula? R1 plus R2 by K square. What is K? K is transformation ratio, that is N2 by N1. 660 divided by 6600. So it will be 66 by, means 1 by, I think 100 it is. 100 or 10? Yeah, it is 10. Not 100, please. It is 10. Yeah, 66 into 10 will be 660. K is 1 by 10. Now R01 is equal to, in ohmic value, is equal to R1. How much is R1 here? 1.75 plus R2 0.015 by K square, means by 1 by 10 will become into 10. 10 square is 100. So obviously this is 1.75 plus 0.15 plus 1.5, it is in fact 1.5. So this is in fact a 3.25 ohms. Answer is 3.25 ohms. This is also D for Delhi, right? See, all are simple questions only if you know the process. Dual of Norton's theorem is dash. Yes, as I told you, Thevenin's and Norton's both are duals. Voltage and current both are duals. Resistance and conductance are duals. Inductance and capacitance are duals. Right? KVL and KCL are duals. Clear? Thevenin's is dual of Norton's. This is direct question from the concept of duality. Next, in an oil circuit breaker, due to heat of the oil decomposes, due to heat the oil decomposes, and the gases are liberated. Yes, which of the following gas usually not liberated in this process? Which of the following gas is usually not liberated in this process? Acetylene, it will liberate. Methane, it will come. Hydrogen, it will come. Ammonia gas is not going to get liberate. Ammonia gas is not going to get liberate from this oil circuit breaker. Next question, please. Which of the following equation is sometimes referred as the Ohm's law of magnetic circuit? First of all, what is Ohm's law? Resistance is equal to voltage divided by current, right? Or current is equal to voltage divided by resistance. This is Ohm's law. Now, in magnetic circuit, flux is equal to MMF by reluctance. Flux is equal to MMF is nothing but N into I by reluctance. Some people will show reluctance as this S symbol also. Okay, yes sir. So option is A. Flux is equal to MMF by reluctance. Flux is equal to what? MMF by reluctance. Magnetomotive force divided by reluctance is the analytical Ohm's law of normal or voltage current resistance Ohm's law, right? Referred as Ohm's law, it's not exact Ohm's law. A 3-core cable, there are dash capacitances found. 3-core cable. So this is how 3-core cable looks. Yes, this is 3-core cable. So this is core A, this is core B, this is core C, right? Now, tell me, all of you must tell. This is phase A. Yes, this is phase B. This is phase C. Between A and B, capacitance will form. Yes, this is C, A, B, I call. Why capacitance will form? A and B, two phases, A and B. Ajay, yes, very good, Ajay. Answer is B. Okay, I'll explain. Listen to the explanation, please. Between A and B, why capacitance is formed? There are two conductors. A and B are conductors. There are two conductors. If two conductors are separated by some dielectric, yes, we are keeping insulation between A and B. We are keeping insulation between A and B for short circuit not to happen. And we keep it. See, this is sheath. This is metallic sheath. This is metallic sheath, and its voltage is 0. See, when capacitance is formed, understand this one. This is very important. If two conducting bodies are having potential difference, are separated by some dielectric, then capacitance will form. Some capacitance is formed. Some capacitance is formed. Some capacitance is formed. Here also capacitance will form. See, this is a CBC, CCA. This we call it as CBN. This is CAN, and this is CCN. CCN. Right? So 1, 2, 3, 4, 5, 6, total 6 capacitance are formed. That's all. That much easy it is. Let's go for the next question. Yes, this is frequency. Yeah. A 3-phase 4-pole induction motor. Yes, a 3-phase 4-pole induction motor. P is equal to 4 is supplied from a 50 Hz source. F is equal to 50 hertz, 50 hertz. Find the rotor frequency when the rotor runs at 600 rpm. So rotor speed is 600 rpm. Is asking to find, this is frequency, supply frequency. Is asking FR. FR is equal to dash. We know that NR is equal to NS into 1 minus S, where S is a slip. Where S is the slip, right? Now that fellow given NR and NS, and we know that rotor frequency is equal to slip times of synchronous frequency, right? S is not stator frequency. Stator is not going to rotate. The rotating magnetic field of the stator is rotating with the synchronous speed. What is that synchronous speed? First of all, see, NS is equal to how much it is? 120 into F by P. P is 4 poles. F is 50. This is 30. Yes, how much it is? NS is equal to 1500 rpm is the speed. 1500 rpm is the speed. Now, yes, observe here. S is equal to NS minus NR by NS, right? So that is equal to how much it is? 900 divided by 1500 is the slip. Now, what is rotor frequency? FR is equal to 900 divided by 1500 into 50. 300s it is gone. Sorry, 530s only, na? 530s it is gone. This gone. So 90 divided by 30 will be 30 hertz. The answer is 30 hertz. Option is A. Right? Option is A. So look at that very simple thing. I given very simple thing. Okay. Only two relationships. That is S is a slip. That is nothing but NS minus NR by NS. And after that, NR is equal to NS into 1 minus S. And after that, FR is equal to S into FS. That's all. Next question. Convert B68 in hexa into equivalent of octal number. This is dead easy. Okay. This is dead easy. That fellow already given in hexa. B68 to the base of 16. What is B? A is 10, B is 11. Write in binary. How to write B in binary? First of all, let's write 8. What is 8? 1 0 0 0 is 8. 6 0 1 1 0. B means 11. 11 means 8 plus 3, right? 1 8 0 4 is 0 1 1. So this is the binary equivalent of that one. Now see how to get from binary to hexa. 4 bits from left side, you group and get its value. That is the basic process of converting from binary to hexa. The reverse is hexa to binary. For every hexa number, you write its binary equivalent using 4 digits. Done. Now if you are grouping 3 bits together, then you get octa. This is how much? Yes, it is 0. 3 bits from right side, you group and go towards left side. How much it is? 4 plus 1, it is 5. Yes, this is 101. This is 5. This is also 101. This is 5. 5550. 5550. Option is A. Option is A. Clear? Next. If a voltage of 10 cos 100t plus 30 is applied to a 50 microfarad capacitor, the current through the capacitor is, see, for this one you need not to solve anything. We know that current in the capacitor leads the applied voltage by 90 degrees. Yes, if you see voltage across the capacitor, if this is VC, this is going to be IC, and current through the capacitor leads the voltage by 90 degrees. 90 degrees. Leading means positive angle in the bracket. So plus 90, if you add for this one, then you're going to get current angle. Magnitude you forget. Say this one I'm least bothered. This one I'm least bothered. I have to check the angles. Because I have to check the angles. If angles are matching, then I go for the magnitudes. Right? I'll go for these magnitudes if angles are matching. But none of the two angles are same. Therefore, angles are enough for me. I should get 100 plus 90 plus 30 is 120 degrees. 120 degrees. So this is what you want the current, right? So IC is equal to V by XC. What is XC? XC is equal to again 1 by omega C. Therefore, IC is equal to V. How much? 10 into omega. Omega is 100 into C. How much it is? 50 into 10 to the power of minus 6. If you solve it, you're going to get that magnitude of IC also. So, but I can say the option is B for Bombay plus 120 it is having. This is not correct. This is not correct. This is not correct. Option is B. So current through the capacitor must lead voltage across the capacitor by 90 degrees, right? Next. Yeah, some questions are given from, in fact, from the root locus diagram, from control systems also. Okay, so going through some part of control systems partially is important. Okay, though that fellow did not mention in the syllabus control systems, but that fellow given some questions. What is saying? The breakpoints of the root loci of a polynomial can occur at, see, breakpoint is a point where more than one branch of root locus meet. At breakpoint, the value of gain k is either maximum or minimum. I repeat the statement. If you want to, you can note down. What is a breakpoint? Breakpoint is the point at which more than one branch of root locus meets, and at a breakpoint, the value of gain k is either maximum or minimum, right? Yeah, anywhere on the complex plane, anywhere on the real axis, at the original only, on imaginary axis only. I would like to say that the question itself is not complete. See, for a breakpoint to exist, I told you two conditions. First of all, the value of gain k should be either maximum or minimum. At origin only, no, this is not correct. First of all, it may lie anywhere. Okay, he's asking about break point. Okay, break away point, not centroid. Centroid always lies on real axis. Break point may be on imaginary axis, break point may be on real axis, break point may be in the complex plane. But for break point on complex plane on imaginary axis to exist, at least the order should be fourth order. At least the order should be fourth order. But this fellow did not given even, see, I will tell you, see, this is sigma real axis, this is j omega imaginary axis. Observe here carefully. Suppose for this one to be a breakpoint, the minimum number of branches required are 2. Therefore, breakpoint exists on real axis. That depends, right? It may exist on right side, left side, or right side. Suppose for the breakpoint to exist here, suppose if there are 2 branches meeting this way, we need its a mirror image also, because root locus is always symmetrical with respect to x-axis, real axis, right? So anywhere on the complex plane, yes, it may be. On only real axis, no. There is no guarantee. That depends on the given question. On imaginary axis only, this is also not correct. It anywhere on the complex plane, anywhere it may exist. Okay, the option is A. I went for the elimination method. He is mentioning only on imaginary axis only. No, there is no rule like breakpoint should exist only on imaginary axis. Real axis only. There is no rule like it must exist at on real axis only. There is no rule that it should exist only at the origin. You have to make this way. You for breakpoint you have to make dk by ds is equal to 0. If you do this, you are going to get s some roots. These are the breakpoints, and you have to check whether these breakpoints are valid or invalid. Validity of a breakpoint you have to check by angle condition. You have to check for a breakpoint to be valid, it must satisfy the angle condition. That is, if you substitute that breakpoint in the characteristic equation must satisfy. Okay. Next, a 9-volt battery supplies 1 milliampere of current in a series circuit, 3 resistances R1, R2, R3. Yes, some network question. Yes, R1, R2, R3, R1, R2, R3 is saying that a 9-volt battery. Yes, he connected 9-volt battery plus minus. This is 9 volt, and the current that is flowing is 1 milliampere. Fine. If the voltage drop across R1, R2, R3 are 1 volt, 2 volt, and 6 volt, this is 1 volt, this is 2 volt, and this is 6 volt. Fine. Find the value of resistances R1, R2, and R3. R1, R2, and R3. This is not a big question. Okay, very simple question. What is voltage across R1? 1 is equal to I is 1 milli into R1. So R1 is equal to 1 by 1 milli is nothing but 1 kilo ohm. Yeah, R1 is 1 kilo ohm. And if I do R2, voltage is equal to current is 1 milli into resistance is R2. So from this one, R2 is equal to 2 by 1 milli. that is 2 kilo ohms. Yes, R2 is equal to 2 kilo ohms. Next term, R3. So 6 is equal to 1 milli into R3. So from this one, R3 is equal to 6 by 1 milli, that is equal to 6 kilo ohm. That is equal to 6 kilo ohm. So 1, 2, and 6 is the answer. 1, 2, and 6 is the answer, right? Option is A. That is very easy question. Question statement looks big, but question is easy. Next, which of the following is not a valid advantage of shell type? Not a valid advantage of shell type of transformer or core type of transformer. See, losses are less. Yes, it is a valid one. Mechanical strength is high. It is a valid one. Copper requirement is less. Valid one. Maintenance is easy. This is not a valid one. Okay, I'm marking. He's asking which one of the following is not valid. Yes, maintenance is easy. That is not valid. Okay, next question. A single phase half bridge inverter has supply voltage of 100 volts DC and resistive load of 4 ohm. What will be the RMS value of the output voltage? What will be the, see, single phase half bridge rectifier? Yes, anyone? Single phase half bridge rectifier. Sorry, inverter, half bridge inverter. So single phase half bridge inverter means output voltage is V0 is equal to Vs by 2. You get Vs by 2. Vs by 2. Okay, you have to take Vrms. Then see, he's saying Vs by 2. It is answer is see, yeah, but this is this way. This way you're going to get half bridge inverter. Yes, half bridge inverter you're going to get this way, right? If you do, see, but he's asking about what? He's asking about RMS value of the output voltage. Yes, he's asking what will be the RMS value of output voltage. See, if you do this, V0 RMS, see, this is the magnitude. This is the magnitude I'm showing, not exactly V0. Okay, single phase half bridge inverter, you're going to get Vs by 2. If you get its RMS value, yes, if you get its RMS value, just a minute, V0 RMS is equal to, see, I can say V0 magnitude by root 2. V0 magnitude by root 2. If you do this, you'll be getting 70.71. You get. Okay, that is very easy question. You can do it. Okay, next question. While incorporating the lead compensation network, the gain factor of the amplifier is given by. So this is very dead easy question. As I taught you in classes, that is, as I taught you in classes, see, Vrms is equal to, yes, maximum value by root 2 for sinusoidal. For sinusoidal, right? Yes. And Vrms is equal to same as that of Vm for square wave. For square wave, use this relationship, you'll get the answer, right? Next, while incorporating lead compensation network, the gain factor of the amplifier is given as gain factor of the amplifier lead compensator. How lead compensator looks? GC of S. Yes, GC of S, some constant k into S plus alpha, sorry, S plus, yeah, S plus 1 by tau by S plus 1 by alpha tau. Yes, S plus 1 by tau by S plus 1 by alpha tau. This constant k may be even 1 also. Yeah, now he's asking, while incorporating the lead compensation network, the gain factor of the amplifier is given as, so what is alpha? Alpha is nothing but R2 by R1 plus R2, and tau is equal to R1 into C. Lead compensator, this is how it looks. This is how it is going to look. This is the lead compensator. So this is V0 and this is Vi. If you observe carefully, the factor will be obviously 1 by alpha. It is going to be 1 by alpha, right? Next question, please. In a coal-based thermal power plant, electrostatic precipitator is used for coal firing? No. Coal handling? No. Ash handling? Yes. Electrostatic precipitators are used for ash handling. Those are used for what? Ash handling. Next question. The dash states that the line integral of magnetic field intensity H around a closed path is exactly equal to the direct current enclosed by the path. See, closed integral of H dot dl gives you the current enclosed, I enclosed. This is nothing but Ampere circuit law. This is nothing but Ampere circuit law. This is nothing but Ampere circuit law. So answer is Ampere circuit law, right? Yes. Arun Kumar, a change of 4% in the supply voltage to an induction motor will produce a change approximately, option A, 10%. So change of 4% voltage to an induction motor, 4% of voltage, supply voltage, right? Yes, will produce a change approximately, right? Yeah, let's answer Mr. Arun Kumar question. Okay, Arun Kumar is asking some question. Yeah, the torque of an induction motor is some K into S into E2 square by R2 square plus SX2 whole square. So torque is directly proportional to E2 square, right? Where E2 is directly proportional to V2, means applied voltage, I can say. And S is also there, slip is there. See, just I'm talking about only voltage, right? Then he's saying that voltage is 4%, it is reduced. Voltage 4% it reduced. Arun Kumar, you can try with this formula. Yes, this is the formula you have to use to know what are the changes that are going to happen if you are reducing the supply voltage or frequency or slip or something, right? Next question, please. Next question. Which of the following characteristics is not desirable in measuring instrument? Not desirable. See, first of all, let's understand the desirable characteristics. Accuracy is very much required. Accuracy, right? Yeah, reproducibility, repeatability, linearity, right? And more torque to weight ratio. All these are the required characteristics. What that is not required for us? Let's see. Linearity required, repeatability required, drift not required. Yes, this is not required for me. Accuracy required. This is required. This is required. Just I am ticking what are what required for us. Answer is this one only. This is not required. This is not a positive quantity, means it is not going to help for us in the measurement, right? Option is C, Ajay. Okay. Calculate the resolution of a 3-digit 0 to 1 volt 0 to 1 digital voltmeter. Why to calculate this? Very easy. 0.001, that's all. After this one, 3 digits you must have, right? 3 digits, right? 3 digit. Option is A, 0.001. Okay, 0.001. Next question. Which of the following is not an example of vector quantity? This is basic, I can say 10 plus 2 level question. See, acceleration is a vector quantity, magnetic flux density is a vector quantity, electric field intensity is a vector quantity, mass is not vector quantity. Yes, mass is not a vector quantity, right? That is very easy. For a synchronous generator supplying a balanced 3-phase load, okay, armature reaction flux is dash in magnitude and rotate at dash speed. You know, for a synchronous generator supplying a balanced 3-phase load, if the load is balanced, okay, and the load is rated, current is constant. If current is constant, the flux that is produced because of the load current is constant, then armature reaction is also fixed. If load is varying, then armature reaction will change. Means current will change, flux will change, armature reaction will change. Here, armature, see, first of all, as it is synchronous generator, it is going to work with constant speed. First of all, constant speed. And see, variable, subsynchronous, no. Constant and subsynchronous, no. Variable and supersynchronous. First is asking about flux. Flux is constant. Okay. Option is either B or D. Okay. Subsynchronous. It is synchronous speed. Flux is constant and speed is a synchronous speed. Speed is always synchronous speed. Yes. Synchronous generator always works at synchronous speed, right? Yes. Next question, please. Which of the following system is an example of closed loop control system? As I told you, some questions are given from control system also. A closed loop control system. Traffic light control system? No, it's not closed loop control system. Voltage stabilizer? Let us see. Bread toaster? It is not. TV remote control? It is not. Option is B. I will tell you. See, bread. How to know the answer? How to know the answer very clearly? Ajay, it's not A. It's not A. Traffic light control system is not closed loop. Why? You tell me. On the road, if you see, if 4 roads are there, 4 road junction is there. This is 4 road junction. Whether full crowd is there, here only one person is there, the time if you set it, the time given for this one, this one, this one, this one, all four directions is constant, 1 minute, 1 minute, 1 minute, 1 minute, right? Why? It is not possible for us accurately to measure the crowd on a road, right? Therefore, next, bread toaster. You put the bread inside the toaster, you switch it on until suppose you have to fix some time. After that time, it is automatically going to stop, right? So bread toaster is also not. TV remote control. See, come on, man. TV remote control is never it is going to be closed loop. Why? Because that is whatever the input you give, accordingly that is going to produce the output. It is not measuring the output at all, right? Next, Thevenin's circuit, VTH is equal to 20, RTH is equal to 20. Find the maximum power transfer to the load. See, maximum that is transferred is VTH whole square by 4 RTH. You may be thinking, sir, have you wrote this formula? In fact, I forgot the formula. Nothing. Even if you forgot the formula also, directly you can get the formula. Yes, this is RTH, this is RL. But for maximum power transfer, RL must be equal to RTH. This is VTH. The current is I. What is the power delivered to the load? Power is equal to P max only. Why? Because when RL is equal to RTH, power delivered to the load is maximum. That is I square. What is I? VTH by RTH plus RL. Nothing but RTH. This is the current whole square into RTH into RL actually, but RL is equal to RTH. So this will be P max is equal to VTH whole square by 4 RTH into RTH. RTH gone, sorry, 4 RTH square. So 4 VTH whole square by 4 RTH. 400 divided by 4 into 20. That is 0, 0 gone, to 20 is gone, for 5 cities. I think 5 watt cities. Please correct me if I did any mistake in the calculation part. Okay. Next question, please. A single phase half wave controlled rectifier is supplied through a 230 volts 58 supply. What will be the maximum output voltage possible? See, maximum, see, Vm by pi it is, no, Vm by pi. So maximum value, not Vm is equal to Vm by pi. So the maximum possible value itself is Vm by pi. That Vm is nothing but what? Vm is nothing but what? Yes, root 2 into Vrms, that is into 230 divided by pi. So root 2 into 230 divided by pi. Option B is the perfect answer for the given question. Next. A 0 to 200 volts voltmeter has a guaranteed accuracy error of 0.5% of full scale deflection. See, he's saying that GAE is always with respect to full scale. So what is that? 0.5%. How much is 0.5%? Means 0.5 by 100 into 200. Yes, 100. This is 2 times gone. So 1 is the error. Then the voltage measured by the instrument is 50 volts. Find the limiting error. Limiting error is always with respect to measured value. See, I can say 1 volt is the error. 1 volt is the error. See, 1 volt you are getting when you are measuring 200 volts, right? The same 1 volt. See, I can write like this. I can write like this. With respect to this 50 volts, how much it is? 1 divided by 50 into 100. How much it is? 52 cities. 52 cities. How much it is? 2% will be the error. Answer is 2%. See, I'll explain you this concept. That is, guaranteed accuracy error is always with respect to full scale deflection, whereas limiting error is always with respect to measured value. Value of error is going to be constant, but the value, what is the value of error? 1 volt. 1 volt with respect to 200 is 0.5%. 1 volt with respect to 50 volts is 2%. Right? That's all. See, magnitude of error is constant, that is 1 volt. Right? That 1 volt, if you are taking 200 volt as reference, full scale deflection as reference, that is called as guaranteed accuracy error. But that 1 volt you are taking measured value as a reference, means not measured value, any true value as reference. Okay, any true value as reference, that is 50 volts. Yes, it is measuring 50 volts. 50, see, 1 volt with respect to 50 volts is 2% of the 50 volts, right? Next, induction type energy meter dash error is caused due to overcompensation for friction, creeping error. Yes, one of the very, very important question. Energy meter is also very, very important, right? Creeping error is the one which is going to happen in the energy meter. Next question, please. The direction element in the reactance relay is so designed that its maximum torque angle is 90 degrees. Yeah, the torque angle, see, if you want to obtain maximum torque, then the torque angle should be 90, right? The next question, please. Direct questions, those are. Which of the following condition must be satisfied to measure the power delivered three-phase load using only 2 wattmeters? See, if you are using 2 wattmeter method, yes, the load may be balanced or unbalanced, but there must be 3 wires. There must be 3 wires. See, 2 wattmeter methods are going to measure, I can say, this three-phase power, right? A load must be unbalanced. No, not required. Load must be connected to the source through 4 wired. No, this is not correct. This is not correct. Load must be connected to the source through 3 wires. Yes. Load must be balanced. This is also not a condition, right? We can measure. Very good. Very good. Yes, Arish. Next question. For series connected SCRs, the static equalization is obtained with help of only resistances. For series connected SCRs, static compensation, or I can say, static equalization can be obtained with help of series connected, only with resistances. Next. For a second order system having its transfer function as h of s is equal to 25 by s square plus 8s plus 25, find the damping factor. See, the question itself is, we have to look at the options. Actually, damping factor means sigma, damping ratio means zeta. But that fellow given answer as zeta only, it seems. 25 by s square plus 8s plus 25. Now, damping ratio zeta is equal to B. You can compare this one with s square plus 2 zeta omega ns plus omega n square. Zeta means zeta, sorry, sigma means zeta omega n. This is damping factor. This is damping ratio. If, see, in place of 2 zeta omega n, how much is there? 8 is there. Then 1 zeta omega n will be 4 only. 1 zeta omega n is 4. But answer 4 is not there in the options. Therefore, he is asking for damping ratio, that is equal to 8 by 2 root of 25. So 8 divided by 2 into how much it is? 5. Answer is 0.8. Option is D. Option is D for Delhi. That is also a direct question, right? A single phase transformer has 200 primary and 700 secondary turns. Okay, if the primary voltage is 100, find the secondary voltage. This is not at all a question. First of all, see, he's asking V2. V2 by V1 is equal to N2 by N1, right? So this N2 by N1 transformation ratio, that is nothing but voltage ratio only. That is 700 divided by 200. The V2 is equal to how much is the primary applied voltage? 100 into 700 by 200. 100 twos, it is how much you get then? 350 volts. Answer is option C, right? Yes or not? Next question, please. Two equal resistances of 10 ohms each are connected in series with 20 volts DC supply. Find the current in the each resistor. See, is this a question to ask? That fellow saying 10 ohm are connected in series, and here that fellow applied how much voltage? How much voltage? 20 volts. Then find the current through each resistor I. So I is equal to 20 divided by 20. That is equal to 1 ampere. Answer is 1 ampere. Option is C. C for Chennai. Right? That much easy it is. That much easy it is. Next, here the question is missing actually. Yeah, the question expression got missed. Leave that question. I will cover that question in the next upcoming session. Okay. So this way, see, we are left with some questions of 2022 and 2021 in the upcoming session. Both I'm going to close in a single session. See, it is always expected some encouragement from you. You must answer in the chat box. Whatever the question you asked in the chat box, I'm answering. In fact, you can type. I told you, you can ask any question, whatever you have in your mind regarding your preparation. If you have any queries regarding your preparation, you can contact to this number. You can contact to this number. Some questions in every live, 1 or 2 questions, I will leave it for you. Okay, I will leave it for you. See, the questions what I leave for you, I'll discuss in the next session. Okay, that's the actually thing I do. Some question asker, sir, when we use R and C combination in static equalization. See, I will tell you what is the purpose of capacitor. It is going to act like surge arrestor, right? Whenever there is a possibility of sudden rise of voltage is going to come, at that times we will use. Okay, right? Ashish, this is Ashish or Anish? Anish D Anish. Okay, so you can contact to this number. Okay, you can contact to this number. YourPedia has started a very good module, exam result oriented module for the people who are preparing for this HPCL. One question here from power electronics I given you as a work. I told you you can directly do it. Okay, if you are not getting the same, we will be discussing the upcoming session. Okay, fine. If you have any questions, you can contact me. Fine.